Hello, everybody, and welcome to the Cosmos Show, the place to be if you're curious about the universe. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here you can pick the brain of astrophysicists, get advice from a space doctor, learn what astronomers have to say about life, and find out what's going on above your head, all in the same place. Join us every other Tuesday live on Twitch and on YouTube. You can chat your questions via Twitch and YouTube. You can also call in and ask your questions live. We'd love to hear from you. The call-in number is 929-205-6099. You can find that down at the bottom of your screen. There's also some other login information that you'll need there to join us on our Zoom link. So give us a call. We'd love to hear from you. This week's show is all about celestial navigation. And here to tell us about it is Brittany Maurer, who is a prospective sailor in the Ocean Global Race. And she also just happens to be one of the Wyoming stargazing leaders. But before we introduce Brittany, we're gonna welcome our co-stars. First, we have the Deputy Director of Education and Public Outreach from the Vera Rubin Observatory. It's Dr. Lauren Corlees.
Hello.
Hey, Lauren. Next, postdoctoral scholar from the Simons Observatory. It's Dr. Nick Galitsky.
Hi, everybody.
Hey, Nick. Next, PhD candidate in astrophysics from the University of Chicago and host of her own YouTube show, Nora's Guide to the Galaxy. It's Nora Bailey.
Hi, all.
Hey, Nora. And last but certainly not least, medical doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hi, everybody.
Hey,
Good
Danny.
to be here.
Yeah, thanks for joining us. Happy to have you. So tonight it is Lauren's turn to tell us all about what she's up to and to give us a little update on the Vera Rubin Observatory. So Lauren, we are all yours.
Yeah, so this week I thought it'd be fun. Last time I talked about the research that I like to do, but I do work for the Vera C. Rubin Observatory. And currently the observatory is still under construction. It's being built, and it's one of these sort of massive observatories. It's taken, almost a decade just to get this far in its construction. And so for me, it's very cool to see all the pieces finally starting to come together and starting to look like a real observatory. But for some context, the way I like to think about the observatory is that we are a building and a group of people and software and hardware all working together to take data that's really going to help transform astronomy. So the way that I like to summarize it, if I had to give it in a few words, is that the Vera C. Rubin Observatory is conducting the legacy survey of space and time. And what's so cool about the observatory is how it's combining a whole bunch of different technologies to do something in a really incredible way. So the observatory itself is the biggest digital camera in the world that we know of, suspended above an 8.4 meter diameter mirror, so a massive, one of the bigger ones in the world. It takes a single image the size of 40 full moons at incredibly high resolution. And so today I'm going to touch on just one part of the observatory. And I think in the weeks coming, I can talk about more of the technology that we're building. But all of this is in the service of trying to really survey the entire sky. So the goal of the survey is to image the entire southern sky every 3 nights for 10 years for an unprecedented look at the dynamic sky. So really, we're going to touch pretty much every aspect of astronomy. And we're really going to revolutionize how we think about the universe as a place that's also changing. It's not just staying the same always. But as I mentioned, we're still under construction. The observatory is coming along. It's being built. And when I started at the observatory back in 2018, the building was in place, but the dome itself that's going to house the telescope was mostly just scaffolding, is what it looked like. And in the last few months, we've made a lot of progress in both terms of the dome and the actual structure that is going to be hosting the mirror and the camera that will be the telescope itself. So if we go to the next slide, and then hit play, I brought a bunch of videos just to show off the construction of the observatory, because it's not that often we get to build something at quite this kind of scale and to really see exactly how long it's taken. So this is a decade ago that we're starting to actually build things on the site, and you can see construction picks up more in 2015. So the telescope is on a mountain in Chile in the desert, regardless of what the snow in the wintertime seems to suggest. And it's really a huge infrastructure that we're building. So there's the giant dome that's going to house the 8.4 meter telescope. But there's also a lot of infrastructure that we're building to help support actually using the telescope. So a way to store the mirror right now, there's coatings on the mirror that make it more reflective that we need to be able to reapply. There are offices up at the dome so people can come and work and actually work on the infrastructure. It's storing the camera. So there's a lot that's going into the building besides just the telescope itself. And it's like finally all coming together. So this is about when I joined, it started looking like this, and it stayed that way for a long time. You can see it's 2020 when they finally start putting up the like cladding around the dome to make it look like a thing that is enclosed and not just like wildly open to the elements. And so now we're in a place where that dome construction is complete, which is really exciting. It like now looks like a proper telescope. And in that last frame, you could see in the inside, what they're also building simultaneously is the telescope mount. So the infrastructure that's going to hold the mirror in place, but also the giant camera that we're building. So if you go to the next video, this is really just a series of videos because it's so cool. What they did at the summer was actually complete the assembly of this telescope mount. And so what this video is going to show is that we actually have, it's 3 different mirrors, but 2 different surfaces. So one in the place where you would expect it to be, and then a secondary mirror that sits above and actually holds the camera too. And so they had to actually lift this top end into place to put it onto the telescope mount. And so you can see that's what they're doing here. This is one of the largest cranes in South America. We weren't sure if it was actually the largest, but we're pretty confident it's within the top 3, which is already kind of cool that they got that large of a crane up there in the middle of nowhere. And they're lifting this into place at a single time. So lifting it up and then going to actually position it onto the telescope mount. So it happened all in a day, but it took them a very long time to plan out and actually schedule and enact all the details that went into doing this correctly and safely. And so if you go to YouTube and watch this yourself, there's like some epic music playing to really underscore exactly how dramatic this moment must have been for everyone, especially that guy. But I'm happy to report that it all went very successfully and the telescope mount is now assembled. It still just blows my mind. It's like the scale of it, once you see the person next to it, it's really big. I think it's almost over. Yeah, and so then one final shot where they'll zoom out. I've only ever seen like illustrations of this happening, and so reminding myself that this is real is super cool. Okay, if we could go to the next slide, I have one more video. Because it's all well and good that it's assembled, but at some point it needs to move. So the goal for the telescope is to image the southern sky every 3 days, which is a really large area. And so the camera takes a new image every 30 seconds. So it's constantly zipping around trying to find a new patch of the sky to take a picture of. And so the actual telescope itself, it looks very big, it is very big, but it's actually quite squat, like it's like very compact. And so the way that it moves, it can actually move really quickly to be able to cover that much area of the sky. And so this was the first time since they've rebuilt the telescope mount in Chile that it actually is moving. So this was also another big milestone for us. So it's not just built, it's not just sitting there, it can actually move. And they had to build a whole new system for how to get it to move so quickly and so effectively, and also to be so stable. So if you want to take a picture every 30 seconds, you need to move, but then you also need to be exactly still in order for the picture to be able to come out correctly. So if it was moving and then had to like ring into place for too long and wobble, that would be bad. So they had to design this whole system to get it to move quickly and effectively. And it's so good, you can see that there's just a few people who are actually moving the dome manually because there's so less friction based off this hydraulic system that they built that a few people can rotate the whole thing. And so now the next stage, now that we know it can move and that the system does work, is to get all the motors in place so it can start moving automatically. Because this telescope, it points based off where a computer algorithm tells it to. There's no single individual that tells the telescope where to go at any given time. And so that's my update. It's like a big set of accomplishments for us that the dome is complete, the telescope mount is complete, it's all moving, and we're finally getting closer and closer to having a complete working observatory, and we're all really excited.
Well, congratulations. That
Yeah.
that is super, super cool. I mean, I think the first question on my mind is when is the scheduled first light of this telescope? What's the timeline from here on out?
Yeah, so we're still finalizing that. So unfortunately, this is still an active construction site. So when the pandemic happened, everything had to shut down because you couldn't have, we didn't know exactly what was going on. We didn't want to have people working in close quarters together. So the whole construction site was shut down for a series of months. People are back up on the site now, but that's definitely impacted our schedule. So we think right now the estimate is about a year delay, a year and a half delay. So maybe sometime around 2024 is when the telescope will be operational. So we're getting there.
Sweet. So you're going to beat Elon Musk to Mars at least.
Woo.
So the
I've got a question.
oh, sorry.
Go ahead.
Oh,
Go ahead,
okay.
Nora.
So I know that the observatory is going to be doing the survey, the LST survey. Is there other observing time planned for this? Is it going to just be doing the survey, or are there going to be like guest observers and stuff like that?
No, it's just going to be doing the survey. So we have a scheduler, we call it, the algorithm that tells the computer where to point. I think it could maybe be what goes into the scheduler can change a little bit. So we are trying to optimize for so many different fields of science that maybe it won't just do all area of the sky covered equally. It might focus, the plan is to focus on specific parts of the sky for a deeper field, or to do things for solar system science, or if some sort of really cool gravitational wave event happens, like maybe putting that into the scheduler. But there won't be an opportunity for people to request time on the telescope for the first 10 years.
Interesting. Thanks.
So I was curious, and I apologize if you mentioned this and I just missed it, but what's the, like, how much of the year, or how many days out of every month, let's say, in this part of the world, is the weather good enough that you can actually image the sky reliably? This is very far outside of my normal realm, so please talk to me like I'm in fifth grade, please.
No, I didn't mention that. And it's actually a good question. I'm not entirely sure that I've ever heard anyone talk about a number for that. I know it's a large fraction. That's why they picked the site, and it is in the desert. So it's pretty much always dry, but you'll see it sometimes in the winter. It's not unlikely for it to snow, like maybe once. So it's not a lot of weather, but there is still some. So I'm sorry, I don't have an exact number for you. I actually don't know. But so it's a high fraction, but not every single night. So
Yeah.
And I guess the top closes when that happens. There's to keep the scope covered, like telescope covered and everything. And
yeah, that's right. You'll saw there's it's like a slit in the dome that can open and close. So they'll also close it during the daytime just to protect the mirror from the elements and everything. So
cool. Thank you.
Yeah, if I'm remembering my facts correctly, the Atacama Desert is the driest place on Earth if you average the weather across the entire desert. So there's really not a better place to have good, predictable stargazing weather.
Yeah.
I guess I was going to speak from my experience up there, which is just it's we go off how much atmospheric water vapor there is, and there's better seasons and worse seasons. There's some variability. I don't know how much that affects you versus microwave, but I will also say there's the advertised number of observing nights you get, which is probably, well, I'd guess over 300. Yeah. And then there's the experience we've had, which is it tends to snow a bit more than advertised, which creates many complications, not just in observing, but also getting up the road and all sorts of shenanigans like that. But I was wondering if, as part of your role in Rubin, will you be going down there? Do you get to see it in person?
Hopefully, that would be nice. Since I'm not actively working on the construction of the hardware itself, it's not as much of a priority to get me down there. But it's definitely a goal to go and to try and see it so we can talk about it more effectively. And for us as EPO, one of our audiences too is also the Chilean audience. And so getting to go down there and getting to know them and having those sorts of connections would be really great too. So fingers crossed if travel picks back up next year, but we'll see how it goes.
Fingers crossed for you. I guess what is the local community you work with down there that you're hoping to engage with?
Yeah, so I mean, the goal overall is just the Chilean audience in general. So for our program, we're building everything online with the hope of being able to reach as many people as possible. But in particular, we're building a pretty extensive education program. And so I think being able to go in and like connect with teachers and to understand the needs in their classrooms too, and how they maybe vary or are similar to the needs of American teachers would be really interesting. So that's something we've started to consider, but to continue to build up those sorts of connections would be fun.
All right, one last question for me. Do you know if there'll be tours?
So there is the capacity for site visits. Yeah, so not right now since it's still an active construction site, but I think in the future, the plan would be able to be to offer visits and things. So yeah.
Do you still get down there fairly often, Nick?
Technically for my role, I've only been down there once, but I'm anticipating starting to go down there a lot more because, it's funny because you're talking about like this whole process of planning crane installs and that sort of thing. And, we're doing that whole process too, but I think our entire, the one I'm working on, the smaller telescope we're working on, Simons Observatory, would fit on your primary mirror. So
yeah, the scale blows my mind sometimes. It's helpful to have the people walking around and feel like, oh, right, it's really big.
Yeah, needless to say, we do not need the largest crane in South America. Fortunately, probably our logistics are a touch easier. Unfortunately, we did not get to blow off the top of any mountains either, so we don't have quite as dramatic footage of our installation, but watching with a close eye all the developments with Ruben, very cool to see.
Yeah, it's coming.
How far is Ruben from like the other observatories down in that area?
That's a good question.
Like, are they all like kind of neighbors, or are they like,
No,
mountains apart?
it's fun because we've got different camps. I think they're in the optical camp, but they're not. Are you associated with the European Southern Observatory at all? I don't think so, but you're somewhere in that vicinity.
I think that's right.
Yeah, I think
I'm showing my lack of geography knowledge.
There's the optical chunk, which is a little farther south because they don't need to be as high up, and then there's all the millimeter guys, us folk, which are the ALMA and CMB telescopes, and we're up like right hugging the Bolivian border, up at 17,000 feet, just scratching away as much atmosphere as we can to get rid of atmospheric water vapor.
Wow, that's cool.
Watching that explosion on the top of the mountain actually made me think of the observatory that we're trying to build here, well, not here where I am right now, but in Jackson, Wyoming. So Wyoming Stargazing has been helping Snow King Mountain to design an observatory and planetarium for the top of the mountain. And the site's been prepared, might actually get a foundation in this fall, so it's really exciting. But there was just an article that got sent out by the local conservation organization that said the title was something like Snow King Post-Mortem. So they're not super excited about the way the summit of the mountain has changed, not just for the observatory, but for lots of other things. Yeah, I mean, I think putting telescopes on the tops of mountains is pretty cool.
Yeah, that all predates my involvement with the project, but I think they did try and do a careful effort to pick the mountain that they were going to put this on to make sure they were trying to talk with people and to take into consideration like the local communities and what they had to say as well when they were picking a mountain. So definitely a thing to consider.
Yeah, and that's good to hear. I've definitely been watching the process in Hawaii with the 30-meter telescope. Doesn't sound like that there's anything like that down there with the scope.
No, so I think, like I said, they tried to have conversations to understand like which mountain it would be okay to blow the top of and which ones they shouldn't. And I think probably being part of a mountain range gave them more options. In Hawaii, there's Mauna Kea for the most part. So that's also a difference. There's also Mauna Loa, but that's,
Cool.
And then the volcano, which is actively erupting. So that's also pretty cool.
Yeah.
That's happening in my life too. So
Don't put a telescope there.
no, I think that would be frowned upon. There is a volcano observatory though. So a different kind of observatory. They're observing different phenomena, but still cool.
There was a segment on Wait, Don't Tell Me on NPR. Maybe it was just last weekend that there's a volcano going off in Spain, I think it is now.
La
And
Palma, yeah.
yeah,
Well, it's
Mm.
part of
yeah,
Spain.
yeah, part of Spain. The tourism agency there is actually trying to get people to come and visit, even though the entire island's been evacuated. Um, they're like actually doing this.
Yeah.
Pretty wild.
The Hawaii eruption is nowhere near that violent. It's mostly contained within the caldera still, so you can go and like check it out and try and see the glow. No, nothing catastrophic as far as I'm aware yet. So that's good.
Well, I'm glad to hear it.
Yeah, me
well,
too.
yeah, Lauren, thanks so much for your update. Super cool. And yeah, keep us posted.
Will do.
Yeah, can't wait to see the progress. All right, it is time for Astro Advice, life advice from astronomers. This evening, we have a quotation from Professor Dame Jocelyn Bell Burnell, who, as a postgraduate student, discovered the first radio pulsars. That was back in 1967. Although that discovery eventually earned the Nobel Prize in 1974, she wasn't one of the physicists who received the prize. Instead, it was her male advisor and one of his colleagues. She didn't complain. In fact, in 2018, she was awarded the Special Breakthrough Prize in Physics, which carries with it a $3 million award, which dwarfs the Nobel Award of $1 million. And she donated the whole thing to create a scholarship fund for women, minorities, and for refugees to pursue careers in the sciences, which I did some research on this. I could only find 2 Nobel laureates who have actually donated their full prizes to create scholarship funds like that. George Smoot, who we actually had a quotation from before, and Albert Einstein actually donated it to his first wife and their 2 children. And this was actually after they were divorced. So nice one, Albert. And to bring us up to the present, just a couple months ago, Dame Burnell was actually awarded the world's oldest scientific prize, the Royal Society's prestigious Copley Medal, which carries with it a $30,000 prize. And she donated that to the same scholarship fund that is actually in her name that she created when she won the Special Breakthrough Prize. So incredibly amazing work that she did both as a scientist and now as a philanthropist. So she rocks. And her quotation for us this evening is the following. Women of my generation who've stayed in science have done it by playing the men at their own game. So I think that is fantastic. And I would love to hear what all of you have to say about it.
I think, I mean, I have so much respect for her as a scientist and as a woman. And I think what really stands out to me about this quote is saying, you know, women of my generation. And it really makes me think how different the experience was for her and for women of that generation. And I have been very lucky, and my experience as a woman in science has been very positive. I really haven't had a lot of these sorts of challenges, and I'm very grateful for that. And I think that women like her, who were really trailblazing through very, very difficult circumstances, I really owe so much to them, and I'm just very grateful.
Well said, Nora.
Yeah, I feel the same. I think, yeah, you phrased it, you put it very well, Nora. And, you know, in my own life, most of the, I guess, the different career fields that I've gone into have been primarily, I guess, male dominated. But what she's, I think, getting at here in this quote is that ultimately, if you stay, you know, you focus on being a professional and on doing a really good job at what you do, that's the most important thing, you know, and then it ends up, you know, being respected with that in mind. So it seems like she absolutely did that and was very successful as a result.
Yeah, I guess it makes me also think too that it's true that I've had a lot of positive experiences, but I've also had some negative experiences, and that there is still this element of it being like a game that I'm playing. And so always trying to think about too of like, well, how can I change that game? Why are these rules that I need to play by when they shouldn't really exist at all? And so continuing to do that work, acknowledging and being very grateful for all the progress that we have made, but still trying to think about how can I make it even easier for the people who are coming after me as well. So that doing what I do can be enough, and not just having to do what I do and more to be considered equal is like still a thing that is very real in science, unfortunately.
Now, I'm not actually aware of any diversity, equity, and inclusion conferences or work that's being done within the field of astronomy. Are any of you aware of any of that?
I'm not aware of a specific conference, but a research team of mine is about to publish a paper on like the female body in space and like specific considerations therein. So related, but I don't know of any conferences. I'd love to hear.
I think we've got a caller actually. Let me admit Mary and see if she has anything she'd like to add to the conversation. Or Marie. Marie, are you with us? Oh, she's connecting to audio. Hi there.
Hi.
Hi, can you hear us?
Yes, I can.
Excellent. Well, thanks so much for calling in. Do you have a question or a comment you'd like to make?
No, I'm really just calling, watching to see my daughter, Brittany Maurer.
Oh, wonderful. She's going to be here in a little bit. She's our special guest tonight.
Yes.
Yeah. Well,
Great.
She'll be tickled that her mom's here to see her.
Yeah, that's for sure.
All right. Well, thanks so much for being here.
Sure. Thank you.
Yeah. Any other thoughts, comments, Nick?
Yeah, I think you're jogging my memory now. The American Astronomical Society, I know at their conferences they have, I think, workshops and that sort of thing, but I don't know dedicated meetings towards this thing. And I know that within our collaboration and departments, there are a number of programs that are trying to take off and promote this type of work and this type of improvement to many departments and collaborations to make a more inclusive environment, make everyone feel welcome, and try to destroy some of these barriers that exist. So the one that I know of is sponsored by the American Physical Society, APS, who's been working on that. A number of initiatives that our collaboration is part of, but I also know a lot of our departments are working with as well. So they are there, they're getting off the ground, they're getting, I think, their feet under them and how to approach these types of topics and how to, do it in a data-driven way that we can make sure that you're actually getting the results that we really want to see. So that's been encouraging to see and encouraging to be a part of. But yeah, obviously still fair ways to go on a number of fronts there in terms of physics specifically, but also astronomy.
Yeah, and I know that NSF, the National Science Foundation, is sponsoring something they're calling the Includes Network. It's an acronym. I forget what it stands for, but it's all towards funding and work that support diversity, equity, and inclusion. And so if there's ways you can apply for grants or for resources or connections, and for some of the big collaborations, including Ruben. So I'm a part of something called the Multi-Messenger Diversity Network. So how do collaborations get to think about this work and participate, and what can we learn from each other as a group is work that we're doing as well. So it's all happening. But the other part of it too is getting that recognized as legitimate work and not just service or volunteering is also like another thing that needs to happen. So.
Yeah, that I would say that's especially true of a lot of grants and that sort of thing. Is making sure that the funding is also there. So NSF in that regard has been a little more progressive than many agencies in that they have a broader impact section that is funded in many of their grants, but it's not as widespread or particularly well funded as it could be.
That's
progress.
awesome. And something that I've actually come across. Oh, I'm sorry, Lauren, were you going to say something else?
No, I was just
Oh.
cheering on progress. Your comment is more
Oh.
interesting.
Something that I've actually run across since starting orbital biodesign about a year ago is that there actually are quite a few like business funding opportunities, grants and things for women who happen to, you know, be small business owners, where it's like a majority, you know, owned by a woman. And that's something that I wasn't aware of prior to starting the company, but it's been pretty neat. So, and I think something that's been reiterated in the business studies, and again, this is separate from astronomy, but, you know, from in the business types of studies that I've done and trying to make sure that we get this company off the ground in the right way, is that across the board, you know, you can look all over Harvard Business Review and all sorts of, you know, really high-speed business-related websites and see that the dividends, so to speak, that are paid by, you know, having a really diverse team are just off the charts. So it's beneficial in so many ways, you know, not just that it's the right thing to do, but it's also just, you know, it makes any organization better on the whole. And so, you know, that's obviously not just talking about, you know, including different genders, but races, you know, ethnicities, et cetera. So it's a cool time to be involved in all of this type of stuff.
Yeah, the federal government contracts also take into account things like women-owned businesses, minority-owned businesses. So from the space end, a lot of that is federal government work. And so if you're the women billionaire out there, that's going to make, you know, the next SpaceX. Let's do it.
Cool. Well, it's encouraging to hear that there's stuff going on in the astronomical community and beyond. Well, it's time for us to move on to the next segment. We're going to be back in just a minute for Looking Up with Wyoming Stargazing's Vice President of our Board of Directors, Dr. Mike Adler, our local virtual stargazer. So join us back here in just a couple minutes, and he's going to share with us some of the amazing photography that he does of the night sky. We'll be right back. Welcome back, everybody. We're here with Dr. Mike Adler, our local virtual stargazer in Jackson. Mike, thanks so much for joining us.
Thank you. I'm happy to be here.
And so you've got some images for us tonight, but these are ones that weren't taken actually in Jackson, even though you did the post-processing in Jackson. Tell us a little bit about how these images were taken that we're going to look at.
Yeah, so these are all taken of the southern skies, and needless to say, we can't do that from Jackson. They're taken in, most of them are taken in Chile and El Sos, and it's about 6,000 feet up. It's a similar telescope to mine. It's a plane wave C17, 17-inch plane wave telescope with a S-big camera. But several of these are also composites, and there's another observatory in Australia that has a astrophysics 1100 millimeter reflecting type telescope, also different design, but we're using that in a couple of these images And then there's a third telescope also in Australia, a Takahashi 106 millimeter refractor. And so one of these images I'll talk about is it's got actually 7 pictures embedded in it. So anyway, so it's quite a challenge to do the post-processing.
Oh, very
But
cool.
a lot of fun. I only do this stuff because I enjoy it. It's a lot of work, but it's also fun.
That's awesome. So what is this first one we're looking at here?
Okay, so the first one that you're presumably now seeing on the screen is something called the Antenna Galaxies. And it's called that because of these streamers that are moving on the side. So there's 2 galaxies here and they're colliding. And that's what's going on. It's in the constellation Corvus. It's not, you can see it from the northern hemisphere as well. It's about the distance to these galaxies. These are pretty far away. They're 60 million light years away. And you sort of have to pinch yourself and so you understand what that really means. That means that the light that was photographed in to do these images left those galaxies 60 million years ago. So these things are not exactly next door. The other interesting thing about, well, as I mentioned, these streamers, this is called by tidal effects caused by the 2 galaxies, and the interaction of the 2 galaxies is causing some of the gas from the galaxies to be streamed out, and that's what's causing these what actually are the antenna part of this
Yeah, I snuck in another image, an ESO image that's a little bit wider field of view. So if you go to the next one, we'll actually see those antennae a little bit better. So if you
a little bit further, this is actually
advance the slide there, Gavin, and we'll see the next one there. There we go.
Yeah, that one is shows the whole thing, something like 500,000 light years across there. So this is a big object, but it's far away. And so in fact, the center part of this is only 5 arc minutes, which is about 1/6 of the size of the full moon in the sky. So the center part is quite small, but it's because of the antenna, it stretches out quite a ways.
Very cool.
This is one of the really classic features of the southern sky, this particular these particular pair of galaxies.
Yeah, I was looking at the astronomy picture of the day today, and another pair of colliding galaxies came up via what are called the mice. And
Yes.
they actually have really similar characteristics, these kind of long like whiskers with them. They're not antenna for the mice, but same type of kind of like mashed up spiral galaxies.
And you can look in these, and if you look at the center of the one, particularly the first one, you can see there's a lot of detail in there. So for a small object, we were able to get a fair amount of detail of the 2 centers. I should also note, I usually have to remind myself to say this, all the stars that are in this image are in our galaxy. No, they're not in that galaxy. These are all in the Milky Way. They're foreground stars and of course, 100 years ago, people would have thought this is just a part of our Milky Way galaxy anyway. Before the great debate was how far away are these things really? And it was because of Hubble and doing his work, and with Henrietta Swan Leavitt's being able to measure the brightness of Cepheid variable stars that allowed us to measure distances at these great distances for the first time. So it ended that debate. In fact, so for the first time we found out that these are galaxies just like our galaxy. Well, not this one. This is different, but it is a pair of galaxies, but like Milky Way is a galaxy.
That's when the universe got a whole lot bigger.
Yeah, sure did.
Nora, looked like you were going to say something.
Oh, I was just going to say, it looks like a heart. It's so cute.
Yeah, that's right. It has a heart shape to it. You look at it with it right, twist your head. Yeah, it's exactly.
It kind of looks like a kidney to me. Oh,
yeah, there you go. It's the doctor talking. We'll take your word for it. All right, Mike. Let's see. What do we have up next? What's the next picture?
Well, I think I'll look at it. Oh, okay. That let's go not to that one. I'll come back to that one.
Okay, let's
There's
go to
one,
the next one.
yeah, which shows the bigger. Okay, let's do that one right now, and we'll do that. That's this is something that has a very strange name called the Running Chicken Nebula. But this particular view of the nebula is doesn't show the head of the chicken. This is just sort of the body of the chicken. But what you're looking at is a Mission Nebula. It's in the southern skies also. It's in the constellation of Centaur.
Mike, we're kind of losing you when you look to your left.
Anyway, okay, yeah. So when this is in the constellation Centaur, and it's 66,000 light years away, not 60 million light years. So this is right. This is in our galaxy, but in the southern skies. It's about the actual size is about 100 light years across at a distance of 6,000 light years. It's an emission nebula, and what that means is you'll notice the bright reddish or the bright star. There's a cluster of stars. They're kind of just a little bit below the middle, and it's that cluster of stars that is exciting the gas. In this case, hydrogen, oxygen, and sulfur gas to re-emit the light. The gas gets excited into a higher energy state and then re-emits the light at characteristic wavelengths. Now, this is what also is called a false color image, so that the colors are done what's called in the Hubble palette, a color scheme that Hubble uses all the time. And so the green is hydrogen, which is the dominant color here. Oxygen is blue, so that center area, that blue-green, is really a mix of hydrogen and oxygen emission. And the outer area is that orangish color is a combination of the green and red to make orange. And the red color is coming from sulfur emission. So there's three dominant colors or gas species that are contributing to the light in this particular nebula. And I should just say that the nebulas are the birthplace of all the stars. So people understand that this is a cloud of gas and dust, and there are, if you'll notice along the edges of this, there are these things called globules. They're little towers of darker gas. In these areas is where stars are formed, and all stars originally were formed in a cloud of gas and dust. And so nebulas are the including our sun, eventually once was in a cloud of gas and dust, and it collapsed to form as gravity took over and builds up heat, gets to 15 million degrees, and lo and behold, you start a nuclear reaction and a star is born. Well, that's going on big time in this particular nebula as well. I should also say that this one is a combination of the wide field of view here comes from a astrophysics RH305, and it has a focal length of about 1100 millimeters. So the field of view here is several moon diameters in size, and the center part where the detail is where those that group of stars are was done by the 17-inch telescope. So I combined the two. I have to scale the sizes of the images so that they are the same. And then, of course, the stars are nice because they're always, you can use those to align the two images together. And it takes a little while. It's a little fussy, but what you get is a field of view for some of these larger objects that allow you to see the big picture.
So cool.
Yeah.
So let's go back to that other image briefly, and then we'll look at the last one. We just have a few minutes left, but let's check it out.
Okay, there's this is the corner of that other image. If you go, it should be a larger view of this particular feature here. Or is this the only one that's left?
That was the only one.
That's it. No, there it is. There it is. Okay, so this is called the Fighting Dragons of Ara. If you look in the center, it looks like there's two dragons attacking each other in the center of this, and it's in the constellation of Ara. So it's in the southern sky. This one is about 4,000 light years away. It's overall about 170 light years across, but it's quite huge in space in terms of the field of view. It's about 5 full moon diameters across. And this is the one that has 7 different pictures in it. It's also, well, before I get into that, it's also an emission nebula. It's in the Hubble palette, just like the previous one was. So it's a big, a very large emission nebula. The star that orangish star that's sort of in the middle is what's exciting the gas in this case. And it's causing again, the hydrogen, oxygen, and sulfur gas to be excited. And then they remit the light into these fantastic shapes here. I think this is personally one of the most beautiful nebulas in the sky. It just happens to be in the southern sky, so we can't see it here, but it really is amazing. Now this one, to get this wide field of view, uses 3 different telescopes. So the overall field of view comes from a Takahashi 106 millimeter telescope, which I think has a focal length of about 800 millimeter. And then there are 2 of these Reticentian, RH305 images that fill in quite a bit of the center. And then there are 7 images from the 17-inch plane wave telescope that get into the detail. And so this was a tour de force to pull all of these 7 different pictures into one. And then if you look at the lower right, there's also something kind of weird there. That was the picture that I passed up. It's actually a planetary nebula that just happens to be also in the field of view of this really large field of view. Normally, for pictures of this particular nebula, you often don't see this because it's off to the side. But that actually is a planetary nebula, which is a nebula that is a remnant of a sun-like star. So a star that is like the sun, after it uses up all of its hydrogen, and then it starts burning helium, and after it burns all the helium, it doesn't get hot enough to burn the leftover carbon, and so it just fizzles away and puffs out into this very large cloud that you're seeing. In this case, it's bluish color. It's in the same field. It's in the same palette, so that blue color is largely oxygen, and the green you see in the middle, little nugget there, is largely hydrogen gas. There's almost no sulfur emission in that part of the image, and the very center of it is the remnant of that sun-like star.
Very cool. So same type of object as the Ring Nebula. I think you've showed us that before. You've got a pretty amazing image of the Ring Nebula.
Yeah, and so you know that previous image, if you remember if you want to flash it up, the one that just showed that piece, that was one of the images that was taken with yes, that one. That shows the detail of that. So that's the image of that was taken with the plane wave 17-inch. So that shows you the field of view of that plane wave telescope. And there are 7 of those images that are embedded in that larger image, including this very one here.
So cool. We're about out of time, Mike, but I do have one question for you.
Yeah.
What amount of time in terms of the exposure time that you've added up for all these different images and post-processing are we talking about here?
Yeah, I forgot to write that down for this one, but this one, in terms of just the imaging time, it was something like probably 150 hours because it's 7 images, and each one of them is on the order of 20 hours each, and so there's a lot of imaging time taken here. Probably 300 or more sub images that went into this. Now, in terms of post-processing time that I did, I get the raw images from this telescope, just like I do from my own telescope. But putting these individually, doing all 7 images one at a time, and then superimposing them on top of each other, I probably spent several weeks on this thing. This took a long time to get everything aligned and the colors balanced across. Each telescope is a little different cameras in each of the telescopes, and so it was quite a large effort.
Yeah. So consider that the 100 hours plus of exposure time and a couple weeks of work compared to the 30 seconds that the Vera Rubin telescope is going to take one image. Pretty amazing accomplishment.
Yeah.
That's why you build telescopes big and use big CCD chips.
Yeah. Yeah. Well, this is of course, that's looking at a tremendous chunk of the sky at once. That telescope. This is looking at a very small piece of the sky.
Yeah. Well, Mike, thanks so much for joining us. We're gonna transition here for our final segment, our special guest. So we'll be back in just a moment with Brittany Maurer. Join us in just a sec. Thanks again, Mike. All right, welcome back. We're here with Brittany Maurer, who does celestial navigation. Britt, thanks so much for joining us.
Hi, thanks so much for having me.
Yeah, I can't wait to hear all about what you do and your upcoming voyage. But first, I'd like to ask everybody the same question to kind of get it started. So, what's the one question that you wish everybody would ask you about what you do, but nobody ever does?
Sure. I'm glad you gave me a little bit of time to think about this one. So for those of you that don't know me, I am a professional sailor. I work as a crew member. I've also worked as a marine technician, and we take college students sailing for 6 weeks at a time. It's a semester abroad program for them. And so a lot of people will kind of ask me how I do it, and they're like, oh, that's so great, you get to go sailing for 6 months of the year. And they immediately think it's some sort of lavish, luxurious lifestyle, which it's not. It's a lot of hard work and a lot of sacrifices. But the one question that no one really asks is, why do you do it? And I think that's a lot more important, because the why is kind of, why are you taking the time to teach students how to sail, how to navigate? We do a lot of oceanography experiments, and at the end of the 6-week voyages, the students come up to me and they always say things like, I didn't know how much I could learn in a day, or I didn't know how much we could accomplish as a team, and things like that. And the lessons that the students are learning about themselves and about teamwork are things that they will carry on with them for the rest of their lives. So I think that, to me, is the most important part about it. It's being able to share those experiences with people who wouldn't have them otherwise.
That is super cool. Yeah, tell us about these pictures and what you do.
Yeah, so I figured it'd be fun to show you guys a few photos. Here are 2 of the boats that I've spent a lot of my time on. One is the Robert C. Siemens. It's owned by Sea Semesters. It's a nonprofit sailing organization. And the other one in the sunset is Arctic Schooner Bowdoin. It's a 100-year-old wooden sailboat that was built for Arctic exploration. So I've spent a lot of time teaching on both of these vessels, and doing, navigation, celestial navigation, and things like that. I'm gonna head over to the next slide. Do a little intro here about what celestial navigation is. And essentially it's sailing around and using the celestial bodies, so the sun, the moon, and then there's 58 navigational stars that are used by navigators to get a position or fix of where you are exactly on the Earth. So on the bottom left of the screen there, that's what we use as a star finder, quite different from the star finders on your phone. But this is kind of old school technology where you have a map of the 58 navigational stars, and then you plop a little sheet on top of it, depending on what latitude or area that you're in, and then rotate that a little bit depending on a few different factors, and that'll give you a view of what stars are in the sky in your area on that day. And then the sun and the moon are also two celestial bodies that are used for navigation as well. Head on over to the next slide. So navigational tools. So what mariners need in order to be able to navigate around is a marine chronometer. So you need an accurate time reading for when you take your celestial sights. A sextant, which is the photo in the bottom right, which is really just a glorified protractor. And that's where you find your object that you're taking a measurement on. Get that measurement, and that's where you want to record the exact time that you're taking that measurement in order to get an accurate position of where you are. And then a couple books, the Nautical Almanac, it kind of has all the tables and stuff of the celestial bodies at different times, and then the sight reduction table, which helps you figure out exactly where you are. So it's great. Most of the math is already done for you, which is pretty huge. And then a chart to plot your position on. And go ahead to the next slide. I thought this was a fun little video of how the sextant works, but basically, you've got your sextant, you get the celestial body in the mirror, so there's two mirrors, and then you use the inclinometer to bring that object down to the horizon, and that's how you get your measurement or your angle measurement for the celestial body. And then you can pop on over to the next slide. Thank you. And so celestial navigation is really great. It's been used for quite some time, but there are a lot of limitations to it as well. You have to be really good with the sextant. It definitely takes a lot of practice getting used to it. Usually we get the students trained up on shore or at anchor. That way they can get used to holding a sextant, looking through it before we're out in a big seaway or swells and before everyone's seasick. So it's good to kind of get hands on there. And then you need to accurately record your time and the sextant reading, which it's pretty impressive on how many times that's missed or things aren't recorded accurately. So we just take a little bit of extra time to do that. And then the weather. So it's great when you have a clear day, you can see the sun, you can see the stars, but that's definitely not the case all the time. So if we can't get a fix of exactly where we are, we do what's called dead reckoning, which is where you estimate your position based on the direction that you're steering and the wind and the currents. And there's a lot more details that go into all of that. So a lot of the sailing that I do, we do use the GPS as well, and we're teaching celestial navigation. So it's really cool to be able to take your celestial measurements and be like, oh, okay, we were only 2 miles off or 5 miles off, which for out in the open ocean is pretty great. But it's cool for the students to be able to practice in that way. And then this is the next big project that I've been working on. I got accepted to sail in the Ocean Globe Race 2023. There's quite a few races that go around the world. This is the 50th anniversary of the first fully crewed race around the world, the Whitbread race. And it's more of a race for ordinary sailors instead of professional racing sailors who are, are all sponsored and athletes and spend their entire careers. And this is a race where either individuals or organizations can enter their boats into it and then race around the world, which is all done by celestial navigation. So some of the stipulations are we're not allowed to have a GPS on board, no really modern technology, as you will. So that's in 2 years from now. It starts in September of 2023. Pretty exciting, getting prepped for that.
Where's the start point?
Somewhere in Europe. They haven't announced the ports that we'll be calling into yet, but somewhere in Europe.
And what all is involved in preparation for something like this? It seems like a pretty massive undertaking. I
Yeah,
wouldn't
sure.
even know where to start.
It definitely is. It's, you know, for any sailing voyage, usually I do 6-week trips, and these will be kind of 4 to 6 weeks before we get into the next port. But it's making sure you have all the supplies you need, making sure your rigging is working, that your standing rigging is, you know, in good condition, that you have spares of everything, that you have enough food on board. And then it's also checking in with everyone about their health conditions, and, you know, making sure everyone's personally set to be offshore for that period of time as well. So it's mostly checking with the boat and the crew, which takes quite a bit of time.
How big is your boat and how big is your crew?
The boat is 59 feet. It's a 59-foot Swan, and the crew, I think we'll have 10 crew on board.
I am very impressed by this, I have to say.
Nice.
I'm a Navy veteran, and we
Neat.
kind of learned celestial navigation, but it was basically like, don't do this, it doesn't work. Just like, and I can't imagine getting on a boat and like sailing across the ocean with just cell nav. That's so impressive.
Yeah.
It blows my mind. That's really impressive.
Thanks. Yeah, I'm pretty excited. Definitely doing a lot of prep work in preparation. I think the last time I did a voyage where we covered up all the GPSs was 2008, and I was a student at that time. So we sailed from Tahiti to Hawaii, and only one person on the boat knew exactly where we were. And then when we got to Hawaii, we were only 8 miles off from the island. So we were pretty impressed there. But yeah, it's definitely, you know, it's not ideal in the maritime world, especially when you're on faster moving ships and moving supplies around and stuff like that. But it does work. Pretty cool.
I'm so curious about those 58 stars. Is it like a couple of the brightest stars? And
yeah, so I should have put a list on here. I meant to do that. So it's 58 of the brightest stars. I think they span over 38 constellations, between 70 degrees south and 89 degrees north. And I'll definitely have to share the list with you, but it's mostly magnitude 1 and 2 stars, so the brighter stars in the sky.
Maybe a bit of a silly question, but do you have like a go-to star, or like, you know, some favorites in that list?
In the northern hemisphere, I mean, Polaris is great, Betelgeuse, Antares, all of the, you know, the brighter
classics,
ones.
all right.
The southern hemisphere, the Southern Cross, so Acrex and those, but yeah, it's definitely, I'm sure you guys are more familiar with the names. Well,
they're all professional astronomers. They don't necessarily know their constellations.
yeah,
Yeah, so Sam's on board. The rest of us are nodding along.
Yeah, it's us amateur folks who.
Yeah, that's very true. You guys are looking at much deeper stuff in space.
That was one of the first secrets I learned about professional astronomers in college. My advisor admitted to me that he didn't know any constellations, or that he knew a few, but that was a few more than most of his colleagues.
Yeah. I guess that's not something I really think about. But yeah, we definitely spend a lot of time just looking at the constellations, pointing out stars, teaching the students how to use stars to find other stars, especially in the evening when you're shooting evening stars. You need the horizon visible in order to take a sight. So when the stars are popping out in the evening, you need to know which ones are popping out first. At dawn, it's a lot nicer because all the constellations are there, and then they kind of start to fade away. But in the evenings, you need to be a little bit more on point with what you're looking at.
Britt, I've never done any celestial navigation, but I'm thinking about like how I find my way around the night sky when I'm like trying to pick out objects for people to see through the telescope. And like, I basically I use the summer triangle, and that's how I like figure out like everything else in the night sky. I'm like, so I'm so curious about like, you've done both, and so I'm like, I just want to know like the similarities that you've seen, or the major differences.
Honestly, it's probably pretty similar to the way that you use the night sky and the way that you've trained me as well to work for Wyoming Stargazing. So Sam and I met teaching an art class, And he was like, oh, you know, celestial navigation, you can read the skies. Let's train you up and get you running programs. And I was like, oh, sure. Okay, that sounds great. Like,
It was an astronomy art class.
It was an astronomy art class. Sorry. Yeah. It was called Art in the Cosmic Connection. It was really, really cool class, kind of art and science. But yeah, in terms of just finding the stars and the constellations, I think it's pretty simple. I think finding the deep sky objects takes a little bit more training and time, but the more I did it, the easier it got. Yeah, it's kind of just looking at certain stars in the sky and how they relate to other stars and the directions that they're pointing and stuff like that. Kind of how you can always use the Big Dipper to find Polaris. Navigating in the Northern Hemisphere, that makes things a lot easier.
Totally.
I think many things to be jealous of here, but just kind of curious, how is it to just be away from all light pollution in the middle of an ocean?
Oh, it's incredible. I remember very vividly one night we were offshore off the coast of New Zealand. We were probably 800 miles offshore, but the sun was still setting and you could already see the Milky Way. And I had never seen anything like it. It was pretty special. Yeah.
Yeah, I mean, definitely the darkest skies on Earth are out in the open ocean. Yeah. Wow, the Milky Way out while the sun was still setting.
Yeah, it was like there was still this deep turquoise just above where the sun had set, and you could still see the horizon, and then the Milky Way was already pretty bright.
Wow, that is super cool. I'm curious about those 58 stars. Are there some that are used preferentially over others? Like, is Polaris like a go-to because it's always fixed and you can get your latitude? Or
Polaris is definitely one that is used a lot in the Northern Hemisphere. And then maybe I'll look up the list really quick because I don't, off the top of my head, I'm not the best at rattling off all the names. Bear with me. Sorry.
No, you're good.
So it's a lot of magnitude 1, 2, and 3 stars. Do you want me to just run through them?
I mean, I would just
I'll point out a couple. Alpheratz, Shadar, Aknar, Hamel, Mirfak, Aldebaran, Rigel, Capella, Bellatrix, Betelgeuse, Canopus, Sirius, Procyon, Pollux, Dubé, Nebula, Acrux, Gaycrux, Spica. Sam, those probably.
I know most of those.
Yeah.
Not all of them.
So you've got a good start.
Yeah. I mean, just a note for folks listening at home to a lot of those names, a lot of those were Arabic.
Yeah.
And the reason a lot of the star names are Arabic was because during the Dark Ages was when there really wasn't much going on in terms of astronomy or really much of anything in Europe. It was the golden age for Islamic astronomers and chemists and biologists and map makers, and they named thousands and thousands of stars. And we still commemorate all their work, basically, saving the knowledge of ancient Greece for the rest of the world by continuing to use the common names of hundreds of stars in Arabic. So it's pretty cool.
Yeah.
Well, Britt,
I think something that's cool too is around that time as well, the Hawaiians were also navigating really successfully using celestial navigation. And so they have their whole own system of doing celestial navigation and even laying out the whole celestial sphere. and that you can still use to navigate around the world today. I think they did it recently. They sailed a boat.
Yeah.
A big canoe. So it's cool that people were reinventing the same system and all sort of came to the same ideas and concepts as ways to get around the world, which is neat.
Yeah, I mean, I think there's some evidence that that Polynesian navigators were using celestial navigation maybe as far back as 10,000 years, which is
How did they account for longitude though? Because until we had accurate timekeeping, that it was really not able to do east-west travel. So I'm just curious, 10,000 years ago, what were they using for a chronometer?
Yeah, it's a big mystery. But there's evidence of them getting from island to island over, hundreds or even thousands of kilometers somehow.
I think part of it, and I don't know if I'll get the whole story, but I think part of it was that they knew to sail, to a certain point where a certain star was directly overhead in the sky. And when that star was directly overhead, they would turn left or right to kind of get them to the islands. But I think it had to do with the azimuth of the stars that they were using to navigate.
That's very cool. I'm gonna have to look into that. Any other questions for Britt?
Are you guys going to have some sort of like social media or something? Like if people follow along as you guys sail? I know you won't have, but it'd be fun to be able to like see you guys take pictures and everything.
We won't be able to post any pictures while we're out there.
Yeah.
They take all our cell phones and all that kind of stuff. We're not allowed to have cameras with GPSs.
Of course.
Oh, wow.
But the race organizers will know where we are. And there'll be a pretty big social media presence, especially when we get into the next port.
Cool. Well, I'll have to cheer you on.
Yeah, and definitely share that with us, Britt. I'd love to put that up on the Wyoming Stargazing website, and we can track your progress.
Cool. Thanks.
Got your first fans.
Yeah, and Britt, I think you remember I remember you telling me at some point that there was still a fundraising effort going on. What you're doing. So tell us a little bit about that.
Sure. So I'm fundraising my spot to sail around the world. It's cost a lot more money than I've ever had. I also told myself years ago I would never pay to go sailing, but this is definitely an experience that I cannot pass up. And after, getting accepted to go, I was kind of like, whatever, I'll just figure it out. So I've been working pretty hard all summer and doing a lot of kind of outreach and trying to figure out how to get sponsors and stuff like that, and fundraising through family and friends and the local communities. So yeah, I've got a fundraising website that people can donate to, and hopefully all that'll work out. But I've been working pretty hard to help fund it myself. So it's been pretty exciting so far.
Nice. Well, Wyoming Stargazing would love to sponsor you. We'll definitely chat about that offline.
Cool. Awesome. Thank you so much.
Count us in. And if you've got the URL handy for everyone who's watching at home, and we're going to post this video on YouTube as well. So if you want to just tell us the URL right now, it'll be in the video, and hopefully that'll drive some more folks to the website.
Awesome. It's fundraiser.com. So FUNDRZR.com. Let me make sure I'm doing that correctly.
Yeah.
Pretty sure. Yeah, FUNDRAZR.com/B goes to C.
Cool. Well, thanks for letting us know, and we'll
thank you for putting that out there. I really appreciate it.
Yeah, I'm glad.
Every little bit goes a long way. And I mean, it's a lot of money, but all the money is basically going to the boat to enable us to do that. So it's pretty cool. It's pretty exciting.
So how many folks will be on the boat total?
10.
10.
Yeah. And I think so far I'm the only one, or there might be 3 of us that are fundraising our spots. So yeah, stay tuned for more.
Cool. Well, thanks so much for being here, Britt. Excited to hear a little bit about celestial navigation and what you're up to. And yeah, can't wait to see your progress going around the world.
Awesome. Thanks so much for having me. Nice to meet you all.
And thanks to the rest of our co-stars for being here, as well as with Dr. Mike Adler, Gavin, our streaming guru, and all the folks behind the scenes who make the Cosmos Show a possibility, especially all of you watching at home. Thanks so much for joining us, and we hope to see you again in a couple weeks. Until then, be well, and don't forget to look up. We'll see you next time. Bye.